Okay, in this final example, we're asked to draw the graph of this exponential function here. Let's think about how each part of this impacts the equation. So, our asymptote. Normally, it's at y equals 0. In this case, we have a minus 9 tacked on the end. So that is going to subtract 9. It's going to lower by 9, which means y equals negative 9 is going to be our asymptote. What about the y-intercept? Well, our y-intercept, normally it's at 1. It's going to get times by 81, and then we need to subtract 9 from it. So that's quite an awful thing. 81 minus 9 is going to be 72. Next most important thing is the growth rate. Okay, the growth rate is actually not growing, it's decaying. So the way we can express that is it's going to be 1/3. In other words, it's going to drop by 1/3 every unit we move along to the right. And the way we can show that, this 3 to the minus x, well, that's the same as 3 to the minus 1 to the power of x, which is the same as 1 on 3 to the x. So I could write it that way as well. This is the negative power thing going on. All right, I'm actually going to put my x-intercept in on this one. Now, you don't have to do this unless it's explicitly asked for. If it is asked for, the questions will be rigged so that the answers come out quite nicely. And just like with polynomials, we find our x-intercepts when y equals 0. So if I take this equation and I substitute y equals 0, oh, it was minus 9 at the end. And I solve this thing, I will get what I need. And it looks like it's not going to have a very nice answer, but it does turn out right. I can add 9 to both sides. So I get this. Divide by 81. This is 1 on 9. And 1 on 9 is the same as 3 to the minus 2. 3 to the minus 2 is the same as 3 to the minus x, so x has to be 2 here. So my x-intercept is actually going to be at 2 units. All right, and this is enough for us to be able to sketch this thing. So once again, I'm going to get my ruler out. I'm going to do my best possible attempt at sketching this thing. Now I need to think about my positioning. Thankfully I can shift things up and down if I need to. I wanted that to be a black line. That's alright, because I can change the color. And I'll go this way as well. Now with this one, remember we need to leave space for a negative asymptote. So I am taking that into account when I do this. Let's go with that. Oh gosh, there we go. Try that again. Yep, just as bad as always. Let's pretend that that goes down there on the line. Okay, might need to use some imagination with this one. All right, let's go. Let's mark our important points on asymptote at minus 9. I'm just going to use a single unit here for representing 9, just because my y-intercept has to be quite high. So I need to leave some space to deal with that. And if I set these too far apart, I'm going to have a really, really tall, skinny graph. So that's going to be my asymptote right there. Okay. So if 1 unit is 9, my y-intercept needs to be at 81, so it's going to be 9 squares. I've left myself nowhere near enough space here, so I'm going to extend that a little bit. Whoa. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is my y, just lost count. There, just there, that's my y-intercept. Okay, so it looks pretty awful, but that's okay. It's a very steep curve, but we'll be all right. Now, my growth rate is 1/3 here. You know what I just did? The y-intercept is not 81, it is 72. It's 9 less than that, so my intercept is actually here. Apologies. There we go. Now, the growth rate we said was 1/3. In other words, it drops to 1/3 of its height each unit we move along. And remember, that is taken from the asymptote. So there should be 9 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9 squares difference here. So we've got to drop down to 3 squares difference here, to 1 square difference here, and that continues. And that's actually been quite nice because you can see it's marked my x-intercept nicely for me. So my final result here, my final graph, will be done by kind of again joining those up. I'm actually going to start down here just because that's a little bit easier to take into account. Try and make this nice and steep. Whoa. There we go. And that will suffice. It's a little bit sloppy, and my apologies that it is a bit messy working on a tablet. This here is at 2. I've shown all my important features. I've done the growth rate correctly. My asymptote is correct. This is as much as you could be expected to do for a graph of an exponential function. Okay, so there's just a couple of examples. The great thing about having computer technology is, you know, if you want more practice, you can just make up an equation, see if you can sketch it, and then plug it into something like GeoGebra to see if you get it right. Also, I'll just make a note, you shouldn't get anything awful like this going on in exams. We will make sure that we provide you a piece of grid that is of sufficient size to be able to sketch whatever you need to sketch for your questions if you were asked to do this in an exam. Okay, so that is sketching exponentials.